Hello again, I'm Jason Frank. This video is a follow-up to my overview video about my thesis project at the University of Tennessee, completed fall of 2011. This screencast will give a little bit more in-depth details to a particular operation that I demonstrated in the other screencast. Specifically, I'm going to show kind of a round trip from the client to the server to get data, bring it back to the client, store data, that sort of thing, to better illustrate what's going on behind the scenes with CakePHP's model view and controller, as well as some of the model view and controller on the client here. So the operation that I want to show is where we have several job versions for a single job, and we're iteratively trying to achieve the desired outcome. And this mechanism where we use a prior job version as a template for a next iteration. I demonstrate it again very quickly. So when I click that, it goes to the database and pulls up the values that were used in that iteration. And then from there, I can tweak further to get what I want. And then if I submit that, data has to be stored. And again, these messages were explained in the other screencast. It just explains all of the steps that need to take place behind the scenes. However, now I'm actually going to illustrate graphically kind of what's going on with each of these steps. Again, I'm not connected to the school's Cuda system at the moment, so it's not going to properly submit to it. So now let me pull up some slides that help to illustrate. So if you're a follow-up developer and you're looking at my code, you can pretty much go step by step with this screencast. You can kind of follow it in the code, I think, with what I'm showing you graphically here. So this is gonna, I'm just gonna go numerically exactly in order what is going on. So first, when I click right there on that that template starter, what's going to happen is I'm going to make a call to the server to CakePHP's controller that's called form. It's called form because it's going to serve up a form to input new data. Now, in this particular case, though, I don't want just default values. I want specific values from a particular job and job version. So I need to pass those values into my form method. Another reason for passing those in there is that my form method is very versatile. It can serve up the default version, or it can serve up just a new job or job version, or both. So this is what allows me to reuse most of the code in form, but for specific cases make it work for what I need. So in this case, I pass those values. Once the form method in the controller is called, basically the task here is to retrieve that job version's values, but I also need to return these enum table values. So recall the design in the entity relationship diagram that I explained. So in the input form, an enumerated set of values for several fields are needed. So number 4 and 5, basically the models need to get that data. Number 6, return it to the controller. Oftentimes the controller needs to do some other processing of the data before actually getting it to the view. So you sort of hand it off to the view then, number 7. Number 8, and actually let me back up there, number 7. So when the code reaches the view, there's PHP and HTML. When it finally leaves the server here, that PHP code will have been parsed, interpreted. So then it's static code that leaves the server. And number 8, it reaches the client then, and it's a combination of the HTML file, the cascading style sheets, and the JavaScript, and those still need to sort of be finish rendering to set up the GUI state. So things like if you were making a new job version here, and as I go over to the type panel, you'll see that this state was already set up. Yeah, the values were there, but this is the default state right there. But we don't want that. We want this already to be set up. So that's what I'm talking about here. So I'm passing some state information, and once all of that gets rendered, you'll get number 9 right here, the view that the user will actually see. And I do make a little side note here that you start to get into the model view and controller on the client when you talk about the job type parameters are stored behind the scenes in the browser. I'll show it again. So each of these types, this pcert, fdk, cert, you see that's not a call back to the server. It's all stored right there in the model on the client. So then number 10, I just sort of have this diagram like the user repeatedly interacts with the web page, certain operations that can just be handled locally on the client, the GUI state gets updated, which renders new views that the user sees. That was some of the exact same thing I was just showing you, where you select different job type and the new panel shows up, until finally, number 11, the user is ready to submit the form. So now we do need to make a call over to the server. And I make a note here that the form method of the jobs controller is again called, but this time it has the job parameter data that needs to be validated and saved. So you'll notice it's sort of overloaded. In Cake's methodology, these view methods, the controller methods that have an associated input view, in this case my form method, oftentimes have this dual purpose, where initially they're just going to serve up the data necessary to provide you a form, and then after you've submitted, you actually submit back to the form method. And now it's like a whole separate set of duties of validating and saving and whatever else. That's kind of their normal paradigm, and you'll see that in all the tutorials with Cake and in my code and everywhere else. Number 12. Okay, now the controller is going to ask the model to validate the data. So, in other words, the controller doesn't validate the data, but he asks the controller, or excuse me, the controllers ask the models to do the validation, because the validation rules are stored there in the models. Okay. Number 13, the models say yay or nay, pass, fail. If anything failed, if one little tiny piece of data did not validate, then the models need to return that it failed. At that point, the controller needs to abort trying to save, or initiate a save more accurately, and instead the models actually store a validation error string. If a validation rule did not pass, it will actually return the error strings somewhat behind the scenes actually to the controller. You don't actually have to do much except propagate back to the view the user's data. Okay, so that propagation back ultimately to the client in their browser of the error string that says your value must be an int or something, it actually kind of happens pretty seamlessly with CakePHP. Okay, but again, you do have to be conscious of the GUI state. You have to start pass variables back from the controller. Okay, so that was in a nutshell. If it didn't validate what you need to do, in this case, I think we're going to assume it did validate it, that everything validated. Okay, so my controller says, oh, everything validated? Okay, then I'm going to want to save, but because I've got all of these tables and something could go wrong, I need to start a transaction first, and then we're going to go down all the saves. So number 15, you initiate a recursive save method on the models. In other words, the actual recursive save method is on the models, but the controller has to say start. Okay, so I have a recursive save method that traverses associations. I think I have a better graphic. Okay, so I have a recursive save method here that utilizes the model associations. That's how it sort of goes from table to table. And let's go back to the ERD here briefly. So for example, I have a form where you can create a new job and a job version all in one fell swoop. So you have to save this guy, then this guy, and then go outward to all of these external tables. Okay. Oh, and by the way, I do have a separate screencast that explains why you can't just use CakePHP's save all method, which can do more than one table, and it wraps it in a transaction, but it can only do from one table to the next, and I need it to go farther. I've got I've got a minimum of 3 levels. So CakePHP's save all would not work. I had to implement my own recursive save method. Okay, so how does that recursion work? Briefly, I explain here that when one table saves, its primary key, which is called ID in these tables, is assigned to the next lower table's foreign key field. So concretely, when I save a job version, for example, first I save to that table, and after you save, you get an ID back, because that's generated by the database. Once I have that ID, as my recursion continues to job version name here, I can plug in, and actually the way it's highlighted is showing you perfectly. Where it says job version ID down here, that corresponds to the ID in the job version table. So that's how recursively you can go outward. And again, this is noting the transaction effect, that if any operation fails, okay. Can't read my own writing for a minute. The transaction rollback causes all tables to return to their pre-recursive save state. That way you don't have some, like an orphan or something down here, and or vice versa. Okay, number 17, we're going to assume that all the recursive saves succeeded. So number 17, the controller initiates some final save operations on models that are unreachable via the recursive method. So there are a few special cases, basically, is what that's getting at. Things like the tags here are not reachable via the recursion, how the recursion uses the associations. You'll find more of that in the code about why, but there's just a few special cases where you can't just traverse recursively. So take care of those. Number 18, finally, everything must have went fine at that point, so commit that transaction and all of those saves will be complete. Number 19, the controller is going to need to start generating directories and files. So back in the app, when let's just save a new one. So here's where you start to see this other stuff. Config file was generated and saved, the Cuda control script was edited and saved, and output directories were created, things like that. So this is graphically showing you what's going on. Okay, so job-3, it corresponds to, in the file explorer, something like this, job-1. These are the job versions. Okay, so it's got to create those. The app has to do that. it makes a reconstruction output directory. Number 20, you're going to have to generate the config.txt. That's for Dr. Gregor's code. And again, that is this guy. Look at him real quick. So that's taking all of those values from the database and formatting them specifically in this text file format for Dr. Gregor's code. Okay. And the control shell script for submitting to the cluster. So that is this guy, and he's a shell script. He looks like this. So the Cuda cluster will actually run this script, which tells it things like the name of the executable and where it's at and stuff like that. Okay, moving on then to number 22. Now you're ready to actually submit the job. Okay. So what you're going to do is you're going to SSH into the Cuda cluster. So this server is, I don't know the name of the machine, ANASI I think they call it. So from there you would need to issue an SSH command, and the way that you're going to do that is by using this SSH key. So I don't remember all of the details, but I believe it's, you have to generate this key ahead of time, and you're going to generate a public and a private key, and then I think it's the public key that you store here on the Cuda cluster, so that then when you later issue this SSH command, you want to be able to issue this SSH command programmatically, of course, because you won't be there on the command line to type in a password. So then when you run this SSH command, you're going to use your private key. My son would like to contribute to the conversation. So you're going to use your private key in this SSH call so that handshake can happen programmatically. And you're also going to pass in this control script. Okay, so moving on to number 23. Okay, so the Cuda cluster then is going to return a string to the caller, which was the controller in this case, and that string, part of it, or the part that we care about is the job ID. Okay. And we need to extract that job ID because we do want to store that in the database. So number 24, we run a regular expression on that string, extract the job ID. Number 25, make a call to the model to save that with that job version that we were just working with. Once that's happened, number 26, we want to change the job version status from prepared to submitted, because since we were able to properly extract the job ID, that tells us that it did submit to the Cuda cluster. Number 27, where are we? Okay, so finally, basically the controller has finally done all that behind the scenes stuff, and you need to, okay, bye. We need to set which view is going to be rendered. So it's, I believe in the code it's called like a redirect. 28 now, and actually let me illustrate that. So after you submit a new version, you'll see that it's redirected to this view. So that's what I'm talking about there. It doesn't give you the form or something. It's that view. Okay, finishing up here, number 28. That view, in other words, the static HTML and CSS JavaScript, gets sent to the client, these flash messages, that's what they're called, flash messages. The CSS, I believe it's the CSS, you have to actually put them as hidden, display none to start with, so that number 29, my JavaScript or my jQuery can fade those in as an overlay that tells the user the success and failure of all activities. And that completes this part of the detailed demonstration. I'm going to have another screencast that's going to show the sort of the round trip and behind the scenes for that Ajax call for the launching of that Fiji applet with those image stacks. So stay tuned for that one, and hope you enjoyed it. Again, I'm Jason Frank, and this is for the image reconstruction project, thesis project for University of Tennessee.